National Electrical Code Article 210.8a states that branch circuit shall not supply several outlet devices or appliances connected to permanent wiring. Article 210.30c states that conductors supplying auxiliary gutters, wireways, and junction boxes within auxiliary spaces shall not be considered as feeders. The National Electrical Code does not explicitly prohibit running branch circuits through multiple units in a multifamily dwelling. However, the combination of these two articles suggests that it is not permitted. Branch circuits are intended to supply power to a single outlet device or appliance. Running them through multiple units would violate this requirement, as they would be supplying multiple devices. Additionally, the conductors supplying the branch circuits would not be considered feeders, as they are not supplying the main load of the unit. Therefore, they would not be required to meet the same requirements as feeders, such as being routed through accessible areas where they can be easily repaired or replaced. The Florida Fire Code, Chapter 6, Section 614.2 states that electrical wiring shall be installed in accordance with the National Electrical Code. While the National Electrical Code does not explicitly prohibit running branch circuits through multiple units, it is generally not permitted due to safety concerns. The Florida Fire Code also requires electrical wiring to comply with the National Electrical Code, which further supports this interpretation. Let's delve deeper into the reasons why this practice is discouraged and how the National Electrical Code addresses the proper installation of branch circuits in multifamily dwellings. Firstly, it is crucial to understand the fundamental purpose of a branch circuit. A branch circuit, as defined by the National Electrical Code, is a circuit that extends from the final overcurrent protection device protecting the circuit to the outlet or outlets. The intent is for each branch circuit to serve a specific load or a limited number of loads within a single dwelling unit. This ensures that, in the event of a fault or overload on one circuit, it does not affect the electrical system of other units. Secondly, consider the implications of running branch circuits through multiple units in terms of safety and maintenance. If an air conditioning unit in one apartment experiences a fault, such as a short circuit, and the branch circuit supplying that unit also passes through other apartments, the overcurrent protection device for that circuit, typically a circuit breaker, will trip. This would result in a loss of power to the air conditioning units in all the apartments served by that shared branch circuit, creating inconvenience and potential hazards. Furthermore, locating the source of the problem and performing repairs becomes significantly more complicated. Electricians would need access to multiple apartments to trace the circuit, identify the fault, and restore power. This process can be time-consuming, disruptive, and potentially violate the privacy of the residents. Thirdly, the National Electrical Code emphasizes the importance of providing overcurrent protection for each branch circuit to protect against overloads and short circuits. Overcurrent protection devices, such as circuit breakers and fuses, are designed to interrupt the flow of electricity when the current exceeds the safe ampacity of the conductors. When branch circuits are run through multiple units, it becomes challenging to ensure that each unit has adequate overcurrent protection. The overcurrent protection device at the panel board may be sized to protect the entire circuit, but it may not provide sufficient protection for the individual loads in each unit. This could lead to overheating of the conductors, insulation damage, and an increased risk of fire. Fourthly, the National Electrical Code addresses the issue of accessibility of electrical equipment. Article 110.26 of the National Electrical Code requires that sufficient access and working space be provided around electrical equipment to allow for safe operation and maintenance. When branch circuits are run through multiple units, the wiring and equipment associated with those circuits may become inaccessible. This can hinder troubleshooting, repairs, and routine maintenance, increasing the risk of electrical hazards. Fifthly, the National Electrical Code outlines specific requirements for the installation of conductors in various locations and environments. For example, Article 310 of the National Electrical Code specifies the allowable ampacities of conductors based on their size, insulation type, and installation method. When branch circuits are run through multiple units, it is essential to ensure that the conductors are installed in accordance with these requirements. Factors such as ambient temperature, conductor bundling, and proximity to other heat sources can affect the ampacity of conductors, and it is crucial to take these factors into account when designing and installing branch circuits. Sixthly, the National Electrical Code provides guidance on the proper grounding and bonding of electrical systems. Grounding and bonding are essential for safety, as they help to minimize the risk of electric shock and provide a path for fault current to flow back to the source, tripping the overcurrent protection device. When branch circuits are run through multiple units, it is crucial to ensure that the grounding and bonding systems are properly installed and maintained. This includes grounding the metal enclosures of electrical equipment, bonding the non-current carrying metal parts of the electrical system, and providing a low-impedance ground fault path. Seventhly, the National Electrical Code addresses the use of ground fault circuit interrupters, or GFCIs, in certain locations where there is an increased risk of electric shock. Ground fault circuit interrupters are designed to detect small imbalances in the current flowing through a circuit and to quickly interrupt the power supply, preventing electric shock. The National Electrical Code requires GFCIs to be installed in bathrooms, kitchens, and other wet locations in dwelling units. When branch circuits are run through multiple units, it is essential to ensure that GFCIs are properly installed and functioning correctly. Eighthly, the National Electrical Code emphasizes the importance of using approved materials and equipment in electrical installations. Article 110.3 of the National Electrical Code requires that all electrical equipment be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, ORL. This listing or labeling indicates that the equipment has been tested and found to be safe for its intended use. When branch circuits are run through multiple units, it is crucial to use only approved materials and equipment, such as conductors, raceways, boxes, and overcurrent protection devices. Ninthly, the National Electrical Code provides guidance on the proper identification and labeling of electrical circuits and equipment. Article 408.4 of the National Electrical Code requires that all circuit breakers in a panel board be clearly labeled to indicate the loads they serve. This helps to prevent confusion and ensures that electricians can quickly identify the correct circuit when performing maintenance or repairs. When branch circuits are run through multiple units, it is essential to properly identify and label all circuits and equipment to avoid confusion and ensure safety. Tenthly, the Florida Fire Code reinforces the requirements of the National Electrical Code. As stated, Chapter 6, Section 614.2 of the Florida Fire Code mandates that electrical wiring be installed in accordance with the National Electrical Code. This means that any violation of the National Electrical Code is also a violation of the Florida Fire Code. The Florida Fire Code is enforced by local fire marshals and building inspectors who have the authority to issue citations and require corrections for any electrical violations. In summary, while the National Electrical Code does not explicitly prohibit running branch circuits through multiple units in a multifamily dwelling, this practice is generally not permitted due to a combination of factors, including the intent of branch circuits to serve single loads, safety concerns, maintenance difficulties, overcurrent protection requirements, accessibility issues, conductor installation requirements, grounding and bonding considerations, ground fault circuit interrupter requirements, the use of approved materials and equipment, and the proper identification and labeling of circuits and equipment. The Florida Fire Code further reinforces these requirements by mandating compliance with the National Electrical Code. It is essential for electricians and building owners to understand and adhere to these codes and regulations to ensure the safety and reliability of electrical systems in multifamily dwellings. Furthermore, it is imperative to consider the long-term implications of electrical installations. While it may seem cost-effective or convenient to run branch circuits through multiple units, the potential consequences of such a practice can be significant. The increased risk of electrical hazards, the difficulty of performing maintenance and repairs, and the potential for code violations can all lead to costly problems in the future. Therefore, it is always best to follow the National Electrical Code and the Florida Fire Code and to design and install electrical systems in a safe and proper manner. In addition to the technical aspects of electrical installations, it is also important to consider the human element. Electrical work can be dangerous, and it is essential for electricians to be properly trained and qualified. Electricians should have a thorough understanding of the National Electrical Code and the Florida Fire Code, as well as the proper techniques for installing and maintaining electrical systems. Electricians should also be aware of the potential hazards associated with electrical work and should take appropriate precautions to protect themselves and others. Finally, it is important to remember that electrical codes and regulations are constantly evolving. The National Electrical Code is updated every 3 years, and the Florida Fire Code is also subject to periodic revisions. It is essential for electricians and building owners to stay up to date on the latest codes and regulations to ensure that their electrical installations are safe and compliant. There are many resources available to help electricians and building owners stay informed about electrical codes and regulations. The National Fire Protection Association, or NFPA, publishes the National Electrical Code, and the Florida Department of Financial Services publishes the Florida Fire Code. These organizations also offer training courses and seminars on electrical safety. In conclusion, the issue of running branch circuits through multiple units in a multifamily dwelling is a complex one that requires careful consideration. While the National Electrical Code does not explicitly prohibit this practice, it is generally not permitted due to a combination of factors, including safety concerns, maintenance difficulties, and code interpretations. The Florida Fire Code further reinforces these requirements by mandating compliance with the National Electrical Code. It is essential for electricians and building owners to understand and adhere to these codes and regulations to ensure the safety and reliability of electrical systems in multifamily dwellings. Remember to consult with a qualified electrical engineer or inspector if you have any questions or concerns about electrical installations. They can provide expert guidance and ensure that your electrical systems are safe and compliant. By following these guidelines, you can help to prevent electrical hazards, protect your property, and ensure the safety of yourself and others. The information provided here is intended for educational purposes only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician or electrical engineer before performing any electrical work. Electrical work can be dangerous, and it is essential to take appropriate precautions to protect yourself and others. Always turn off the power to the circuit before working on it, and use appropriate safety equipment, such as insulated gloves and safety glasses. If you are not comfortable performing electrical work yourself, it is best to hire a qualified electrician. They have the knowledge and experience to safely and properly install and maintain electrical systems. By taking these precautions, you can help to prevent electrical hazards and ensure the safety of your home or building.